When researchers want to reproduce the effects of specific substances on the human body in the laboratory, they use cell-based biosensors. But their production is expensive and intricate. As part of the Biography project, a brand new manufacturing method was developed right here at the Fraunhofer-IBMT. Dr. Thomas Felten explains the process. There are different types of biosensors. The biosensors that we have developed as part of our research project are typically made by using printed circuit technology. This process involves the use of gold electrodes, which unfortunately makes the sensors very expensive. We have now developed a new printing process that's reminiscent of the process we all know from newspaper printing presses. This straightforward roll-to-roll process is used to print the sensors and make their production very affordable. The electrodes are made of graphene-based ink, so the key material here is graphene. During the first step of the sensor production, we print the graphene electrode structures onto a foil. In a second step, we coat the electrodes in the same unit and also with a protein layer during the same cycle, which ensures improved cell adhesion. In the last step, the printed foils are then combined with a bottomless corrugated sheet. To increase the conductivity of the sensors, Dr. Felten and his team intend to print very thick structures. This creates a big challenge because the thicker the graphene layer, the longer it takes to dry. And the ink must be dry before the foil can be wound up again. This is made possible thanks to infrared light, but there are more aspects to consider. Unlike the newspaper printing process, it's crucial to remember that we will add cells to the sensors later on. That's why we're very limited in our choice of materials. All materials must be biocompatible and non-toxic. The printed biosensors are inside the well plates. Cells are inserted before the measurement and various substances added that are required for the respective test. The outer connection pads form the electrical connection. In doing so, the impedance can be recorded during the entire time, allowing for continuous monitoring of the measurement and knowing when it's been completed. This gives way to a variety of possible applications. Our project addresses two applications. One application is a system for the validation of antiviral substances or vaccines. The second application is meant to enable us to conduct long-term toxicity studies designed to replace animal testing in the future. Dr. Felten and his team are confident that they are very close to the practical application of the printed biosensors. We see enormous potential in all this, and especially when it comes to the validation of vaccines or antiviral substances. Our process does not perform endpoint detection, but we record the results throughout the measurement and immediately detect when a test is completed. And this, along with the low cost, will ensure that our system can be increasingly used in the future.
Wird dazu führen, dass dieses System verstärkt eingesetzt werden kann in Zukunft.